So nuclear fission. So run unstable radioactive nucleus. Two unstable radioactive nucleus are here. So when it has the unstable bits, definitely it will radiate the energy. So it is in the excited state. So that energy is very much in that active uh, active uranium. So out of Hahn, it's a man who discovered that nuclear disintegration. So uranium 235, the uranium. So was is the Les Wegener and the Franz Strassmann. These are the scientists to discover the nuclear fission. So the nuclear fission is a compound nucleus. So now we can combine it with the neutron with the heavy nucleus that is split into two nucleus. That is barium and krypton. So neutron is combined with the uranium. Those excited state, that is compound nucleus. Then it gives the barium and krypton and three neutrons. So the number of neutrons of reactant and the product are equal, but only three neutrons are not equal. The three neutrons are emitted in separately. So adding that 56 and 36 is not equal to the uranium 236 because it's 92. The three neutrons are emitted into use the three neutrons is combined with that another three uranium 235. So is the equation neutron uranium 236 barium and krypton plus 3 neutron plus it releases the 200 mega electron volts. So neutron impact uranium 235 and become 236. It is unstable. So it makes that two elements plus 3 neutrons. That 3 neutrons is again factored with the another 3 uranium 230. So 3 second thread of uranium 235, it again releases 3. So totally now we are having that 9 neutrons and releases the large amount of energy. It's a large amount of energy. So finally to this uncontrolled chain reaction, it's the atom bomb. The controlled chain reactions, that is so this nuclear reactor. So it has the main part of the uranium containers, that is nuclear fuel, control rod, heat exchanger, and coolant, and then shielding. Okay, then moderators. These are all the important things in the nuclear reactors. The next thing is nuclear reactor. It's a schematic diagram. See that it's a core fuel. Fuel means we are using the uranium. Uranium is the fuel. Uranium or plutonium is used as a nuclear fuel. So that is fixed here. And fuel or moderator, that is inside the nuclear reactor. Fuel or moderator, we are using the fuel and moderator. Moderator is a coolant element. We are using a B2O, H2O, or liquid sodium. These are all the things that are used in the moderator. Then it is a heat exchanger. It contains water. Then control rods. Then control rods are used to control the nuclear chain reaction. Then control rods, cadmium and boron is used in the control rods. Okay. So it's a pump. Then that heat energy is given to the next thing. It is a nuclear reactor. It's a fuel. Fuel is uranium 235. Uranium 235 naturally it will get only very small amount, 0.7 percentage. The remaining uranium is uranium 238 in a uranium 238 is not used for the fuel because it is an abundant material. So to convert that uranium 238 into 235, it's called the process of enrichment of uranium. So using that we can produce 2 to 4 percentage of uranium 235. So using that we can produce the fuel to the nuclear reactor. So in that nuclear reactor, plutonium or barium is also used in a neutron source because we need the neutron to conduct the nuclear chain reaction. So plutonium or barium is used to produce the um, neutron source. So using that, it will produce the neutron. So using that, we can conduct the chain reaction. Then moderators. Moderators is used to slow down the fast neutrons into slow neutron. Fast neutrons into slow neutron. So slow neutrons only reacted with the uranium and it will start the chain reaction. That's why we are using the moderator. So moderators are used in the nuclear reactors are B2O, that is hot water, or liquid sodium, or water. So that is depending on the reactors. Depending on the reactors, again, when the neutron is emitted from the source, it is given the energy to the uranium, and it is not it does not stick into the uranium pellets or the fuel. So like a billiards ball. So it will slow down the. So we can slow down the neutron. It will only transfer the energy. Now it's not sticking to the uranium 235. Next thing is control rods. Control rods are used to control the nuclear chain reaction because the 2.5 number of neutrons are produced each reaction. So if you are not controlled the number of neutrons produced in the nuclear reactors, it will go uncontrolled chain reaction. So to control that, we can use the cadmium and boron. This is a control rods. So using that, we can maintain the number of neutrons produced inside the nuclear reactor. Suppose that value is that is critical value. Critical value means that the number of protons produced inside the reactor is equal to 1. Then equal to 1 means it's a critical. Suppose that value is more than 1, it will go uncontrolled chain reaction. Or it is less than that 1, it's not the chain reaction stops. So using that, we can control the chain reaction. Next thing is shielding. Shielding is used to surround the concrete wall for the safety purpose. And cooling system. Cooling systems are used in ordinary heavy water, liquid sodium, or water. So that is used for the cooling system. So it can extract the heat from the nuclear reactor. So using that, we can produce steam. Using the steam, we can produce the power generation. Power generation. We can generate power. So this is a nuclear reactor. So schematic diagram of the function animation of the nuclear reactor. So here, it's a nuclear reactor. It's a coal. Initially, we are using the coal to produce the power. Nowadays, we are using the uranium. So uranium is fixed inside the nuclear reactor, and it's a control rod, and it's a heat sink. Furnace, the steam generator, it's a steam. So steam is produced in the chamber. So water, D2O or H2O or liquid sodium is inside that. So fuel elements. So fuel elements is the uranium. So uranium is inside the fuel. This place inside the nuclear reactor. So these are all the bundles of fuels. This is fixed inside the nuclear reactor. So this is called reactor cool. And this is the moderator. Moderator, it is used to slow down the fast neutrons. So when neutrons are collided with the uranium, it will produce the chain reaction, gives the large number of neutrons, that is thermal neutrons. So thermal neutron energy is very less, that is 0.4. So it is bombarded with that uranium, it will give the 2 element and plus 3 neutrons. Again, the 3 neutron is collided with that another uranium atom. So chain reaction takes place. So it produces large number of neutrons inside the nuclear reactor. The chain reaction or the chain reaction. So the 3 neutron is collided with another 3 atom. Again 3 neutrons are produced. The next thing is for one reaction. 2 or 2.5 neutrons are produced. Averagely, we can take 2.5 neutrons are produced by the reactor. Ordinary water or heavy water, that is P2O or H2O is used as a moderator. It will slow down the neutrons. So see that neutrons flowing inside the nuclear reactor, the P2O slow down, makes collision with the neutron and it is slow down the speed of the neutrons. See H2O, it slow down the H2O, P2O, whatever it is, it will slow down the neutrons. So the slow neutrons are produced inside the nuclear reactor and it's bombarded with the uranium. Again, it produces the fuel neutron. Control gas. Suppose that produced neutrons are produced inside the nuclear reactor is uncontrolled. That means large number of neutrons are produced inside the chamber. So using the control gas, we can absorb all the excess neutrons. Cadmium and boron. Cadmium and boron metals are used for the control gas. So when the control gas is inserted between the fuel cell, that cadmium boron absorbs the neutron. So it is slow down the nuclear chain reaction. So it slow down the chain reaction. So all the neutrons are absorbed by the cadmium or boron. Any one material is used in the nuclear reactor. So now the very less number of neutrons are there. Again, suppose the neutrons are in pieces. Again, we can put the cadmium and boron metal. So using them, we can control the chain reaction inside the nuclear reactor. So that when the nuclear chain reaction takes place, to which large amount of heat energy, that heat energy is passing through the pipe and is given to the coolant. Then coolant is water. Water absorbs that energy and get heat exchanger. That is a water. Water, it gets a steam. Steam is produced. So it boiled and produced